Hi everyone. So in this video, I want to talk about file systems. We'll look at how a storage device actually records data when you write to a file, how files get copied and moved, and how folders play into organizing files so that we as humans can actually find them. We'll also talk about a little bit of a misconception I see, especially with my younger students, in relation to how files work with the programs that we use to read them. So to get us started, I want to talk about how a drive, a storage device, actually gets ready to hold files. So like we discussed in our previous video, our storage devices are basically a bunch of little circuits that can store millions of little ones and zeros. So we can think of that almost like a shelf with a bunch of these little tiny blocks here, one after the next. And in the beginning, when we first have a brand new hard drive, never been plugged into a computer, all of that information on there is useless. We could think of it as it's all zeroed out. We could think of it as it's just arbitrary zeros and ones. But in order for the drive to actually be usable by a computer, the very first thing we have to do is what's called partitioning that drive. So when we partition a hard drive, all that we're doing is telling the computer that it needs to start keeping track of what has gone where on that device. And so the way that it does this is it actually creates a little bit of information right at the front, something that works like an index or a table of contents at the front of the book. So in the very, very beginning of this partition, there will be some information that talks about the partition itself. It says, oh, well, this is, let's say, like 26 blocks or something like that. That's how much space I've got. And this is the version, the order of information for this type of partition. It's a FAT32 partition or an NTFS or an ext4. They're all different ways of ordering this index. It's basically just saying, here is the drive, here's how the rest of it's going to be ordered and how big it is. And then after that, it reserves a little bit of a space, a couple more blocks for that table of contents itself. And then all of the rest of the drive is still empty and unorganized, but now we've got room to track when something is actually written to this drive. And this formatted partition, if you've ever worked in Windows, gone into your My Computer and seen those drives with letters like the C drive and the D drive, what those are actually referring to is some partition that either you created when you installed Windows or that was created for you when you bought your computer. And that C drive, that might even be a label that's right here in this little yellow block right in front with the other drive information. So that is how our storage device gets ready to start recording files. Now I want to talk about what happens when we've actually got some file data. So say I want to now write a file. I'm running a program like, let's say, Notepad, and in my Notepad, I go and I hit the save button. What that's going to do is bring up a little dialog where I have to usually pick a folder and then type in a name and click save. So when you click save, what you are doing there is you are telling your computer, take some data that's in your stick of RAM, your running memory, and copy all of those blocks over into a storage device. And so what has to happen as part of that is your partition that you've created already, that drive that is ready to store files, it goes into its index. And in that index, in these green blocks here, we've got empty space for new file records. And what it will do is it will take that name and that folder that you picked in your dialog, and it will write them into one of these empty blocks. It'll say, oh, you're saving recipe.txt. So your file name is going to be recipe.txt. Your folder, you saved it on your desktop. So let's say it was just /desktop on this computer. And then it's going to have to scan through all of this space and look for somewhere that it's got enough room to actually write this file. And let's say this was a really inefficient file system. It just picks a random spot and it says, oh, look, there's empty space around block 12 here. There's nothing written there. So it decides, I'm going to start recipe.txt on this 12th block. It's going to then copy from your running memory all of that text data for your recipe. Let's say it takes up 4 blocks, and then it gets to the end of the file. So in this file record, in the green index, the table of contents, it's going to record that it put this thing in block 12, and it's 4 blocks long. And then in the future, when you go to try to open a file and you say, oh, well, I want to open on my desktop recipe.txt, it can scan through this table of contents, this green area here, say, oh, well, I am in the desktop. So first, look for a record that is in the folder desktop. Once it's found those records, it's going to say, okay, does any of these have the name recipe.txt? And assuming it finds one, then that's how it will actually open your file when you open it to read that recipe in the future. It'll say, okay, I have found recipe.txt that is at block 12. So it goes to that part of the drive and it loads those blocks back into your running memory from that location that it found in the table of contents. So that is the basics of how file systems write files and read files in this partition that you've created. The other thing I want to talk about is, well, what actually happens when we copy a file or move a file? So copying is actually the simpler of the two here. It is the one that makes the most intuitive sense. So if we think about this, say we have this drive right here that we had at the end, this file that is here in this index, that is at this location in these data blocks. And I say, oh, well, I want a copy of this because I want to start making changes to it. What that means is these 4 blue blocks, I actually want those same 4 blue blocks to appear somewhere else. And so when I tell the computer to copy the file, what it's going to do is first scan through its table of contents here in the front, find that file we want to copy. It's going to say, okay, I know where this is. It is located at 12, and it goes on for 4. And it has this name, it has this folder. You give it some new name that you want to copy it to. So the first thing it's going to do is go create a new file record for the copied version of your file. It's going to create a new record in that table of contents that says, oh, well, you know, maybe I actually want to start at 22 instead of 12, and the name will be whatever new name. And then it's going to take those 4 blocks, and instead of moving from running memory to storage, it's going to go from this part of storage to that part of storage. Say, read it from here, write it there. Read it from here, write it there. And the original part, that 12 blocks that was there before, or the 4 blocks that were there at 12, still stay exactly where they were. But now what we end up with is the same information copied a second place on our drive. And now we have these 2 versions of the file at 2 different places. And when we write one, we only edit whichever version corresponds to the name of the file that we look up in the future. So that shows us how we copy a file. Now the tricky thing to think about is moving a file. Because remember, We said on our storage device, folders are just part of the table of contents. So if I moved from the desktop to my documents folder, say I wanted to drag that recipe off the desktop so I don't lose it, what actually happens on the storage drive here? These blocks don't need to go anywhere because the information in the recipe hasn't changed. You know, the ingredients are here, and then the cook time is here, and the whatever other steps are in your recipe are all written down exactly the same before and after the file moves. So when we move a file, all we actually do is just edit the table of contents. In your partition that your computer has created, you're just going to go find the file that you're moving or renaming and update that record. Say, oh, well, it's not in desktop. It's in whatever other folder you put it in, documents or pictures or wherever you want to put it. The rest of the record stays the same and the actual data on the drive stays the same. And if you've ever noticed, sometimes when you go to move a file, even if it's a 1 gigabyte, 2 gigabyte, 5 gigabyte file, you do that move and it happens seemingly instantly. Not always, but sometimes. And when that's happening, that's because all you're doing is updating the table of contents. Even if this file was hundreds or thousands of these blocks, the only work your computer has to do is find the right block here in front and just edit that one little bit of text that tells you where the file is. However, note, this only works if you're still in the same table of contents, if you're still on the same disk partition. On the other hand, if I tried to move a file, let's say from my desktop onto a flash drive, then a flash drive that I plugged in on a USB port is a completely different partition. It's got its own table of contents that's on the little drive itself that you plug in and pull out. Moving a file to another drive isn't actually possible if we think about it. What we'd need to do is copy that file, actually read all of the bits on our drive, and this pink arrow in this case would be on a completely different rectangle with its own little table of contents. We'd be copying out to that third rectangle entirely. If you tried to move the file there, what you'd actually be doing at best is copying it and then deleting the original copy after you're done. So that sort of shows us a little bit of why it is useful to think about what is actually going on with files when we use them, either in our programs or just as a normal user of our computer, because it can start to explain some otherwise really strange behaviors about how long files take when we're copying them or reading them, and also what we can expect, why there are constraints around folder names or file names because of this index that's in the front of your file partitions. So that is the basic mechanics of reading, writing, copying, and moving files. The other thing I do want to talk about in this video is talking about folder hierarchies and paths. So as we said, all of these files that we have on our hard drives here are just ones and zeros that we're slotting into some spot here. They all have a unique name and folder combination, but we as humans would have a very hard time finding our files if there was just all of these things scattered randomly across our drive. It would be hard for us to keep track of what's where and have some mental model of where things live on our computer. So what we end up doing as human users is using folders as a sort of nesting way of creating organization. So remember, these folders, no matter what we put, is just some path in our table of contents. But the way we normally think about our computer is more like a tree, that somewhere on that drive that we've got, that storage device, that partition, there is a root folder. A folder that is at the very top. On Mac or Linux, we usually represent this with just a slash as the path. And on Windows, it's a drive letter. So it might be like C: or D:. And that top level folder is things that have no folder, things that have no path. That is just where they go. And inside of there, normally we end up seeing a couple different subfolders. We'll see a folder for all the user information, usually a folder for programs. On Windows, it's literally called program files. On Linux and Mac, it's usually called /bin. Folder for other system information, you know, the Windows folder in Windows, or the /lib folder on Mac and Linux. And as we go down from this general root folder, we can get more and more specific. You know, inside the users folder, you'll probably have one folder for each account on the computer. You might have a folder for your own user on your computer that you're using to watch this. You know, if you're on Windows, it's probably C/users/ whatever name you use when you log in. And that home folder is generally anywhere that you go to save a file is going to be somewhere in there. And every place that you think of on your computer, things like your desktop or your documents folder or your downloads when you use a web browser, all of those are generally just folders inside that home folder. And as we chain each of these subfolders and subfolders together, the way that this actually gets represented in the folder path that's stored in that table of contents is by putting a slash after each nested subfolder. So to go back to our original example, say we have this recipe.txt that's saved on our desktop. In that table of contents on our partition, we would store the absolute path to that file. And that would be slash, because that's our root, /users, /home, to say I'm going down to my home folder, whatever my user account is, /desktop, because we were in the desktop folder, and then /recipe.txt. So this is telling me, from the storage device's perspective, just some tag that is unique for the location of this thing. But as a human, what this path is telling me is, okay, open up my C drive, go in the users folder, go in my folder, go in the desktop folder, and then you should be able to see a recipe.txt there. So that is great. It's like a full street address. Like if you're writing a letter, writing out the entire, here's the house number, here's the street, here's the town, here's the state. But normally, you know, we don't need all of that information all the time. Say, you know, I was telling you we're both in the same town, and I'm just telling you what street and number another house is on, where to find that thing. In the same way, on our computer, we don't always need to start from the root. The storage device will use this absolute path, but sometimes we can get away with a relative path. All a relative path is a path that doesn't start from the root folder. Instead, it starts from somewhere else. So a common example of this is that a lot of the times we will use relative paths from the home path. So if I was saying, what is the relative path from the home, from my user folder, I would say, oh, well, that relative path is just desktop/recipe. You can usually identify these relative paths because they don't have a drive letter or a slash in the front. For our programs, once we start writing programs that work with files, these relative paths will all be relative from the folder that your program is running in. So wherever your Python code, if you were in Python, is actually saved, if you try to write a relative path, it'll be relative to that Python file. So that shows us another way to think about these folders. And it shows us how we can actually find files in a particular location, sort of what the general structure is of our folder system on most computers. So the last thing I want to look at in this video is talking a little bit about one big common misconception. It's actually the reason that this video exists at all. And that is that there is this idea, especially among my younger students, those who are taking one of my classes right out of high school, and that is this idea that files live inside of the application that you used to produce them. So let's take a look again at our file storage here. You know, where we have some drive that we've got on our computer, and here it's saying, oh, well, recipe.txt lives in the desktop folder, starts at block 12, and that gives us this data right here. If you notice, none of that information talks about what you use to open that file. That file is ultimately just some text, which is ultimately just some ones and zeros. We could actually use multiple different programs to open that same file. We could use Notepad, we could use the Kate text editor, we could use Sublime text editor, we could use the Z text editor, and all of them know how to read a .txt file. Nothing about file data is actually trapped, locked into one particular program to read it, and in fact, even the place we saved this file has nothing to do with the program that we used to open it. Often, I have students stop by office hours and they go to show me work that they've done, a program that they've written. And I say, okay, where did you save it? And the thing they tell me is, oh, I saved it in my text editor. And I say, no, but what folder? And they say, oh, well, it was in the text editor. And so I say, okay, go open it. And they'll double click their text editor. They'll click the file menu and go to recent files. And because they've opened something else or they've logged off and restarted their computer, they don't see it in recent and they don't know where to find it. And I'll say, okay, so let's go look at your file explorer. And they'll say, well, I don't know where it is. I saved it in the text editor. And they will not have remembered what folder it was in. So the reason I relay this story to you is that the best way to think about the location of your files is not based on the program you used to write it, but instead based on the folder that you used. Remember, we have this hierarchy that is a great organizational tool for humans. This file system is pretty agnostic to what operating system we're in. It's pretty much the same whether you're in Mac or Windows or Linux, but you can extend it however you want. In your documents folder, you could have a school folder, and in your school folder, you could have a course folder. And if you do that, if you keep your files well organized like that, then finding them becomes simple. Even if you decide to change programs, halfway through a course, you say, oh, well, I was using this text editor, but now I like that one better. Your files will still be in a structure that makes sense, and you'll still be able to find all of them even when you open up that new text editor. Every operating system, whether you're on Mac or Windows or Linux, has a file explorer program whose only job is to give you a nice visual interface for navigating from folder to folder, double-clicking a folder, and then you see what's inside of it. So you double-click the users folder and you'll just see the home folder here. You double-click your home folder, you'll just see these folders here that are inside of it. The terminal also works this same way, where every time you type cd, you give it a path and then you can ls or dir to see just what's in that path. If you get used to navigating your files this way, you're going to be in much better shape for understanding where your information is actually stored and how to read it in different contexts as you start writing programs that use files themselves. So that is everything I wanted to cover about file systems here. We saw how file records actually get stored on a storage device. We've seen how they get copied and moved, and how we as humans organize our files into folders. So hopefully this is useful information for you. It helps clarify some of what you've already been doing for years or even decades of your life. But from here, we are going to be talking about other kinds of storage and running memory in our programs, talking about variables and how we write them. So look forward to that, and I will see you in the next video.